Hi, everybody. It's Miss Rose. I am coming to you with my kids' toys to talk about our new unit. We just finished area, so now we're going to move on to surface area. What's the difference between surface area and area? Surface area is just what we call it when we are finding the area of a 3D shape. So you end up finding the area of each of the faces and add it all together. It's the total surface area when you find all the faces, and it's called the lateral surface area if you don't find the area of the bases, if you only find the rest of the faces. We're mostly going to focus on total surface area rather than lateral surface area, but that'll come up a couple times. Today, we're going to focus on prisms and pyramids. So in this video, you're going to learn about prisms, and in Mr. Millington's video, you're going to learn about pyramids. Prisms are just 3D shapes that have congruent and parallel bases. So the one that I'm holding is a cube, and all 6 of the faces are congruent. So you'll see what I mean by prism when we look at other examples other than a cube. Let's first look at one of these vocabulary words is a net. Let's look at a net of a cube real quick. If I took this cube and took it apart and unfolded it, there's actually 11 different ways that I could unfold it, and that is all of these nets that I showed here. So I just thought that was kind of interesting and wanted to show it to you again. All right, we're not just going to focus on cubes that have all sides congruent, though. We're going to focus a lot on rectangular prisms, which is just a fancy name for a box. So what does the net of a box look like? Well, it's a little bit more complicated because it's a bunch of rectangles instead of a bunch of squares. So I'm not going to require you to draw a net every time we find the surface area of a rectangular prism. Instead, we could just draw the faces. If you would rather draw a net, go for it. But I'll show you what I mean. I like to just draw each face separately and find the area that way rather than thinking through the whole process of how to make a net. So the rectangular prism that we're going to look at in this video is a Kleenex box. This is actually the first video that I made when we were home because of COVID, and I made this big deal out of let's look at Kleenex because that's really hard to find at all the stores. So it's kind of crazy looking back at going through that now. And luckily we can find Kleenex and toilet paper at stores again. But a Kleenex box is an example of a rectangular prism that you see all the time. So here's what I mean about my strategy. I draw all the faces. Well, how many faces does a rectangular prism have? It has a top, a bottom, and then 4 other faces. So there's 6 altogether. So what I usually do, and I don't even try to be super careful and draw them big or small or whatever. I just kind of draw 6 rectangular faces. And then I label them with all their dimensions and I try to find the area of it. So let's start with the top and bottom. Those are 9 by 2. 9 by 2, 9 by 2. So 9 times 2 is 18. We'll just do some quick base times height calculations. All right, let's move on next to the right and left-hand side of the Kleenex box. That is 2 by 4.75 and 2 by 4.75. All right, let me multiply that out. I'm not trusting my mental math at this time. So I did it in the calculator and it is 9.5 and 9.5. And then finally, if we did the front and the back, this one's a little bit harder because I see the 9 labeled, but this 4.75, I can move over here. So this one is 9 by 4.75 and 9 by 4.75. All right, let's do the base times height and see what that equals. 9 times 4.75 is 42.75. And then all that I do for the total surface area is I just add those all up, all 6 faces. So I'm going to abbreviate this total surface area, TSA. And I'm going to go 18 and 18, 9.5 and 9.5, and 42.75 and 42.75 for a grand total of 140.5. And then I could put units on this. These were all in inches, so it's square inches because I'm still finding areas. So that is how you find a total surface area. So I recommend this method instead of drawing a fancy net. just drawing 6 quick rectangles, labeling them, and finding the area. I do find that it's hard to stay organized with all these calculations without drawing a picture. So I'm going to highly recommend that you make a quick sketch. What other prisms are there besides rectangular prisms? Well, let's take a look at a triangular prism. Prisms are named by their bases. So this one's really interesting because all of you looking at this probably think this side that I'm coloring in is the base because it's the bottom, but it is not. Remember I said a prism has 2 congruent parallel bases. So it's actually these triangles are the bases. So that's going to be important to know when we start studying volume later in the year. So we can draw all the faces. I have 2 matching right triangles. And then how many rectangles do I have? Take a look at it for a minute. I have this one on the left. I have this one on the bottom. And then I have this slanted one. So I'm going to draw 3 rectangles. Don't be mistaken. They are not all 3 the same. In fact, all 3 of them are different. So we have to be really careful. So the triangles are each 3 by 4. The rectangles, let's see, the one on the left is 3 by 4. The one on the bottom, it doesn't look like it, but it's actually a square because it's 4 by 4. And then what about this one? It's 4 by what? We don't actually know. You have to do Pythagorean theorem. So a lot of times for triangular prisms, you're going to have to do Pythagorean theorem either to find the dimensions of one of the rectangles or sometimes even to find the height of the triangle. This one's a right triangle, so we have the base and height, but we still need to do Pythagorean theorem to find that hypotenuse so that we know the other dimension for our rectangle. So you should hopefully know this one already. This is the most common of our Pythagorean triples that we said you should just memorize. It's a 3, 4, 5. If you know it, you literally do not have to do this calculation. You can just put a 5 on it and move on and call it a day. If you don't know it, then you have to do all this work to do the Pythagorean theorem. So if you're going to memorize any of them, I'd highly recommend 3, 4, 5 because it is going to come up in a lot of problems. And then all I have to do is do a quick area. Just don't forget for triangles to divide by 2. Base times height divided by 2. So the area is not 12, it's 6. The rectangle that's 3 by 4 though, rectangles you don't divide. 3 by 4 is 12, 4 by 4 is 16, 5 by 4 is 20. So the total surface area is, let's add them all up. We have 6 and 6 and 12 and 16 and 20 for a total of 60. There's no units on this one, so I'm just going to say square units. Let's do one more prism. I could have thrown all the different complicated shapes in that we've studied in recent weeks, like trapezoids. I decided to go with hexagons for this one. Thought it would be good practice to do our hexagon thing again. So again, the hexagons are the bases because those are the congruent parallel faces. And then all those rectangles, those are just the lateral faces. So how many rectangles are there? That would be an important thing to think about. Well, they're attached to the hexagon. So there are 6 of them. So I'm going to draw 6 rectangles. Sometimes people don't draw all 6. Sometimes they just do 1 and realize that they need to multiply it by 6. And then there are 2 hexagons. Do the best you can. Doesn't have to be perfect. All right, we have to remember our hexagon thing. So remember that we split it up into a bunch of triangles. And then we dropped a height, which splits the 2 into 1 and 1. And then don't do too much work. The height using 30, 60, 90 triangles. If the short leg is 1, the height is going to be 1 root 3. So the area of one triangle is base, which is 2, times height, which is 1 root 3, divided by 2. Leave the root 3 out. 2 times 1 is 2, divided by 2 is 1. Root 3. The area of the hexagon is 6 of those put together. 6 root 3, so that's the area for each hexagon. That's the hard part. The rectangles are all congruent. They're 5 by, what is the other dimension? Look closely at the hexagon. If it is a regular hexagon, which I'm realizing now I should have specified in the problem, it's a regular hexagon, all the sides are 2. So all of these are 5 by 2. 5 times 2 is 10, so this one's going to be a pretty easy one to calculate because 6 tens is 60. So if you were wondering earlier when I mentioned the lateral surface area would have just been 60. So maybe I'll write that down. Lateral surface area is just 60 square feet, but the total surface area is the 60 plus the 6 root 3 and the 6 root 3, which adds up to 12 root 3. Don't combine the 60 and the 12 root 3 because 12 has a root 3 on it and 60 doesn't, so they're not like terms. So I'm going to put feet squared on that. A lot of times I put it in parentheses just to show that the feet squared goes with both parts of the surface area. So now we're going to try for homework to find a few surface areas and make sure to ask any questions so that we can master this. See you in a minute.